Okay, so we are going to work on 7.1, adding and subtracting polynomials. Within this section, we're going to have 4 different learning targets we're going to address. The first is being able to use polynomials to solve world problems. That you can write and classify standards in polynomial or in standard form, classifying them additionally. We're going to be able to add polynomials, and then we're going to be able to subtract polynomials additionally. Now, as you can see in your notes in the first few pages, they're dealing with algebra tiles. So you should have went through that activity in class already. So really where we're going to start is all the way on 7.1, page 6. Okay. What we're going to do is we're going to start with monomials. Okay, monomial. Okay, is a number, a variable, or a product of a number and one or more variables with whole number exponents. Okay, similarly, the degree of a monomial is going to be the sum of the exponents of the variable. Okay, the degree of a non-zero constant term is 0. Okay, but the number 0 does not have a degree. Okay, so what we're going to do is we're going to start with a little table and identify the degree of each of these monomials. Okay, so here a monomial of 10, just regular 10. Okay, it is just a constant number, no variable, means the degree is going to be 0. Okay, 3x. 3x to the first might be a better way to look at this. So when we have x, it's implied that it's x to the first. So the degree is that exponent on the variable, which is 1. Okay, 1/2 times a times b squared. Well, we have, again, an exponent of 1 on that a and 2 on that b. So to find the degree of this monomial here, what we're going to do is we're going to take the exponent here of 1 and add to it 2. 1 plus 2 is 3. Okay, then negative 1.8m to the 5th. Again, we're going to take that variables or the exponents on the variables, add them together. Here we only have a 5, so our degree is just going to be 5. Okay, so those are the degrees of monomials, and these are all examples of monomials. So let's go ahead and determine some things that are not monomials and why they're not. Okay, hey, so if we look at this first one, 5 plus x is not a monomial because we are adding and or subtracting monomials. So if you're adding or subtracting other monomials, it's not going to be a monomial at that point. It will then become a polynomial, which we will discuss in great length on the next page. Okay, 2 divided by n, okay? This is not a polynomial or not a monomial because you're dividing by a variable. Okay, can't divide by a variable because when you divide by a variable, you have a negative exponent. And with this, we're looking for only whole number positive exponents on our monomials or polynomials. Okay, 4 to the a power is not a monomial due to having a variable in the exponent. Okay, so if you have a variable in the exponent, it's then considered an exponential function or equation, which is not an example of a polynomial or monomial in which we're dealing with today. Okay, and actually these two are very closely related to each other because dividing by a variable indicates that we really have a negative exponent. So these are kind of two in the same, they just look different, but having negative exponents is a reason to not have a monomial, and it's a different type of function at that point. Okay, so what we're going to do first is start with a good old example of finding the degree of each monomial. Okay, we're going to start here, and then I'll have you work through the monitoring progress ones as we typically do. Okay, 3a, we're going to find the exponent on the variable, okay, or the sum of exponents on the variable. Okay, in this situation, it is just going to be 2. Okay, on 3b, what we're going to do is we're going to have x to the first, y to the third. Since I have multiple variables within this monomial, I'm going to add them together. Okay, so we have 1 and 3 together, which is going to be 4. 3C, again, I have multiple variables. Since I have multiple variables, I'm going to take the sum of the exponents. So 3 and 3 would be 6. Okay, and then I have just -3. This is a constant value, no variable. Means since there's no variable, the power on that variable would be 0 because it's just 1. So no variable means the degree is going to be 0. Okay, so if you are watching this video on the other end, what I'd like you to do is pause the video and try number 10 through 13 on your own and unpause it when you're ready to check your answer. Okay, 10 through 13, here we go. Again, multiple variables, so we're going to add them together. 3 and 2 together is 5. Okay, -20.5 is a constant value. No variable means the degree is going to be 0. Okay, number 12, -3x to the 4th power. Okay, this would just be x to the 4th power, whatever our variable is, since there's only one variable, will be the degree. And then lastly, we have 5/3 times y. The exponent on this y is 1. So the degree of this polynomial, or this monomial rather, is 1. Okay, let's go to the next page. Now, what we did discuss was monomials, which is one term. Now what we're going to deal with is polynomials. Polynomials is going to be made up of monomials. So really what a polynomial is a monomial or a sum of monomials. Each monomial in a term of the polynomial. Okay, a polynomial with two terms is a binomial. A polynomial with 3 terms is a trinomial. Okay, this is pretty straightforward. Mono 1, bi 2, tri 3. Anything after that, I'm sure there's a fancy name for it, but as far as this class goes, I think it's acceptable to just say if it has 5 terms, we'll just call it a 5-term polynomial. 17 terms, we'd call it a 17-term polynomial. So anything after 3, that will be acceptable. Okay, now the degree of the polynomial is slightly different. Okay, it's going to be the greatest degree of its term. So you're going to find the term with the largest degree, and then that degree will be the degree of the polynomial. Okay, a polynomial in one variable is in standard form. So this is something we're going to be doing is in standard form when the exponents of the term decrease from left to right, meaning we're going to have the highest degree on the left and the largest degree on the right. And when you write a polynomial in standard form, the coefficient of the first term is the leading coefficient. Okay, so this is going to be addressing our second learning target, which is I can write polynomials in standard form and then also classify them. Okay, let's look at our first example. Write each polynomial in standard form and then identify the degree and classify each polynomial by the number of terms. So here are the 4 things that we're going to have to be able to do is find the standard form, the degree, the leading coefficient, and the type of polynomial. And then you're going to be given a table just like this with the terms each written out or with the polynomial written. You have to write in standard form the degree. In each of these, you'll be given this table is what I'm trying to say on your learning targets in your test. So standard form. Okay, this one's going to be impossible to ruin it or screw it up because it's only one term. So since it's only one term, you just write it as is and it's in standard form. Okay, the degree is going to be the degree of the highest term here. So we have a degree of 4. That's the biggest degree. So that is going to be my degree. Leading coefficient is the number multiplied by the variable with the largest degree. Okay, I'm going to say that again. The number multiplied by the variable with the largest degree. So what's the number multiplied by the variable with the largest degree here? It would be -3. And what type of polynomial it is? The type of polynomial is dependent on how many terms. We have 1 term in this example, so this would be a monomial. Okay, for B, standard form, we want highest exponent to lowest exponent. So we're going to find the variable with the largest exponent here first. That's going to be 5x squared. So that's going to go first. Since it says plus 5x squared, we're going to have a positive 5x squared here. Okay, the next thing we want to do is write the next highest exponent or term with an exponent. So we have an exponent of 2 and then an exponent of 1 here, an exponent of 0 here. So we have an exponent of 1 here. So that will go next. And it is negative here, so it's going to be minus x to the first there. And then lastly, a 4. So now I'm going to see a lot of students write just 4 here, but that's a positive 4. So we need to write plus 4. So this expression here is going to be written in standard form, highest exponent to lowest exponent. Now the degree is going to be the highest exponent in any of your terms. So that should always be in the front if you wrote it in standard form. So here we have x to the second. So that's going to be our degree, highest degree. Okay, leading coefficient. Once again, number multiplied by the variable with the degree. So here we have x to the second. That's our degree. And the number multiplied by it is 5. Okay, again, that should be the very first number written in standard form. Okay, then the type of polynomial. Well, how many terms do I have? 1, 2, 3. I have 3 terms. Since I have 3 terms, that is going to be considered a trinomial. Okay, 4C. Again, here, I want the highest degree first. So my highest degree is q to the 5th. And then I have 8q. That's a positive 8q, so I need to write plus 8q. And what's the degree? Well, the degree here is the largest exponent on a variable, which for us is 5. And then the leading coefficient. Well, what's the number multiplied by the variable here? Well, if I have q to the 5th, that means I have 1 q to the 5th. So that means my leading coefficient is just a 1. The type of polynomial it is depends on the degree. Okay, and the degree, or not the degree, the number of terms. I have 2 terms here, so that makes this a binomial. Okay, so you're gonna have a problem just like this when it comes to your learning target problems as well as your test questions. So take a moment and work through 14 through 16 here. Pause the video and unpause it when you're done and ready to see how you did. Okay, so I'm assuming that you've already paused to do 14 through 16. So now what we're going to do is we're going to do the standard form for 14. Okay, so here, this is my highest degree. That's going to go first. Now, what you have to be careful about is this is a minus 9z here. So we're going to have a negative 9z right out at the front because it's minus. Now, this 4 here is positive, so that's going to go plus 4 right out on the side. Okay, I have negative 9z to the first. So my degree is actually 1. All right. So then I have a leading coefficient. Leading coefficient is the number multiplied by the variable with the degree, which is going to be negative 9. My polynomial has 2 terms. Since it's 2 terms, this is going to be considered a binomial. Okay, 15, highest degree first, which is negative t cubed. Okay, so negative t cubed. Then second highest degree would be t to the second, and that's a positive t to the second because there's no minus sign out here. So this is going to be plus t to the second, and then minus 10t. So that's what it's going to look like in standard form. Okay, the highest exponent on a variable is 3, so my degree is going to be 3. My leading coefficient is the number multiplied by the variable with the degree. So here I have negative t squared to the third. So negative t to the third means negative 1 t to the third. So my leading coefficient is negative 1. I have 1, 2, 3 terms. Since I have 3 terms, this is going to be considered a trinomial. Okay, 16. Here I have 2.8x plus x to the third. Well, x to the third has the largest exponent, so that's going to go first. And then plus the 2.8x. I know it's plus 2.8x because it's positive. There's no minus sign out here. My degree is the largest exponent on a variable, which is 3. And the leading coefficient, number multiplied by x to the third, is 1. So this is 1x to the third. So my leading coefficient is 1. and I have 2 terms. Since I have 2 terms, this is considered a binomial. All right, so like I said, you're going to have a problem just like this when it comes to test and learning target problems. So make sure that you have these down. Okay, 2 more pages. Okay, now what we're going to do is we're going to work on adding and subtracting. Okay, so if you went through the tile activity that we did in class, you should know that I can only add or subtract like tiles. So they have to be the same type of tile. So what does that mean for us when we don't have those in front of us? Well, what it means is it's pretty easy. I can only combine x squareds with other x squareds. I can only combine x cubes with other x cubes. I can only combine x's with x's and constants with constants. So the first thing I want to do is I want to reorganize these problems so that I have those like terms next to each other. So for example, I'm going to start with the highest degree first. So my answer is always written in standard form. Okay, so I have 2x to the third. And what I'm going to do is I'm going to look for any other x to the thirds. Okay, here it is. Or no, here it is. I have a plus x to the third. So that's going to be my next thing. It's plus x to the third. Okay, I have all my x to the third written. Now that I have my x to the thirds, I'm going to go down to x squareds. So I'm going to look for x squareds. Here's my first one, negative 5x squared. And now I'm going to keep looking for other x squareds. Okay, here's one, plus 2x squared. Okay, once I have all my x squareds done, which I do, I'm going to move on to regular x to the first, or just x's. So here I have 1x. And I'm going to look for anything else that goes with that. And nothing. So then I can go on to constants. Constants are going to be just numbers without variables. And so I have a -1. Okay, then what I'm going to do is I'm going to start combining the parts that can combine together. So for example, these two together, 2x cubed plus x cubed, 2x cubed plus 1x cubed would be 3x cubed. Negative 5x squared and plus 2x squared. So negative 5 plus 2 would be -3. So this is negative 3x squared. Nothing combines with this x, so I just get to copy it down. And nothing combines with this constant, so I'm just going to write it down. And then this is going to be my answer. Okay, again, cubes with cubes, squares with squares, x's with regular x's, and constants with constants. Okay, so that's how you add. Okay, so 5b, we're going to do the same thing, just try to reiterate the concept. Okay, again, I'm going to look for the highest exponent first. So as I look through here, okay, I have a 2. I have a to the second power. That's my highest exponent. That's what I'm going to do first. So I'm going to find 3x squared. And then I'm going to look for any other x squareds. Okay, right here. Okay, then after I have all my x's, x squareds, I'm going to look for my x to the first powers, or just x's. There's my x. There's my 4x. Then constants, -6, +10. Okay, then I'm going to combine the parts that combine together, and they're organized in that way. So here, 3x and x, 3x squared plus x squared would be 4x squared. Okay, x plus 4x, 1x plus 4x would be 5x. And then here, -6 and +10. -6 and +10 would be +4. Okay, and then none of these can be combined together because none of those are like terms to each other. So they are just the answers here. Okay, so generally speaking, I feel that addition or subtraction is really not that much more complicated than some of the other stuff that we've done. It's mostly finding like terms and combining them. Subtraction is basically the exact same thing. The only difference is that we have to, we're going to change it into addition of the opposite. So really what this means is I'm not just subtracting this first part, I'm subtracting all 3 parts here, all 3 of them. So what I'm going to do is I'm going to first start by distributing a negative. Okay, so I'm going to distribute a -1 technically. So I'm going to multiply all those parts by -1. but the first part gets to stay the same. So the -1 times -2 will be +2. -1 times +2 would be -2. And -1 times -4 would be +4. So really, for the most part, most of the kids just say, hey, they just flip, they just change negative to positive, positive to negative, negative to positive. And that's all that it does. Okay, then the next thing I want to do is the same thing that I did above. Once I've distributed that negative or I've passed that through, all I have to do is reorganize and get the parts that are together. For example, 4n squared is going to combine with 2n squared. Then -2n combines with nothing, so it's just -2n. But then I have my 5 and my 4. Those will combine together. Then I combine the parts that combine together. Again, my n squareds will combine together. 4n squared and 2n squared will be 6n squared. Okay, -2n combines with nothing, so it's just going to be -2n. And then 5 and 4, those will combine together into 9. And none of these are like terms, so that's going to be my answer. Okay, 5D, same thing. I have a subtraction problem. So here I need to distribute that negative. Okay, get each part sign flipped. Okay, need to be careful here. It's positive inside the parentheses. So that means it's going to be negative down here. It's negative inside the parentheses. So that means it's going to be positive down here. And again, -1 times -8 will be +8. It's negative up here, so it's positive down here. Once I distribute that negative and just flip the sign of everything on the right-hand side, I'm going to reorganize the parts that can go together. I'm going to start with my x squareds. So I'm going to have 4x squared minus 3x squared. I'm going to have -3x and x. And I'm going to have 5 and 8. And then I combine these parts here. 4x squared minus 3x squared is going to be 1x squared. 1x squared can just be written as x squared. Okay, -3x plus x. -3x plus 1x. -3 plus 1 is -2. So this is a -2x. And then 5 and 8. 5 plus 8 is 13. And that is how you add and subtract polynomials, okay? Okay, now you gotta be careful in the monitoring progress. Make sure you pay attention to which ones are plussing and which ones are minusing. It doesn't give you bulleted examples like that, okay? So otherwise, pause the video, go ahead and try these problems on your own. Unpause it when you're ready to check your work. So at this point, I'm assuming that you've already tried these problems and you're ready to see how you did. Okay, so again, on 17, I'm going to reorganize B's with B's, constants with constants. So my B's are going to go together. And my constants are going to go together. Okay, B plus 4B would be 5B. -10 and -3 is -13. Okay, 18, it's a subtraction problem, so I need to distribute that negative. Now the left side stays alone, but the right side is going to change. So opposite of -4p will be plus 4p. Minus p minus -p would be plus p. And minus -1 times +3 is -3. Okay, again, all these signs just flip. Okay, then I'm going to organize. I'm going to go p squared plus 4p squared. Then p plus p. And then plus 3 and minus 3. And then I can start to combine. So p squared plus 4p squared together would be 5p squared. p plus p. 1p plus 1p would be 2p. And then +3 and -3 is 0, so I'm not going to write anything. You could write +0, but it's unnecessary. Okay, 19 is an addition problem again, so I can just find the parts and reorganize right off the bat. Okay, so we have x squared and 7x squared. Okay, -x and -x. And then -2. So I've reorganized it, and now I'm going to add the parts that add together. X squared plus 7x squared is going to be 8x squared. Okay, -x and -x. -1x and -1x is together is going to be -2x. And then nothing combines with that, so it's just going to be -2. Okay, number 20. Okay, so monitoring progress 20. This is a subtraction problem, so you need to distribute the negative throughout. So I get -k plus 5. This is positive inside the parentheses, so now it's negative outside. It's negative in here, so now it's positive. Then I'm going to organize the parts that go together. -3k squared has no pair, so that's just what it is. -k, again, has no pair, so that's just going to be what it is. And then we have 5 and 6 are going to go together. Okay, so the only parts that actually can be combined are the constants here, constant of 5 and a constant of 6. When I add those together, I get 11. So my final answer, -3k squared minus k plus 11. And again, make sure you're writing your answers in standard form, which I've demonstrated now 8 times on this paper of how to do that, highest exponent to lowest. Okay, let's move on to the word problems, and then I get you your practice problems to work on. Okay, so we have a penny being thrown straight down from a height of 200 feet. So we have a penny here, and it's being thrown down. Okay, at the same time, a paintbrush is being dropped from a height of 100 feet. So here they have the paintbrush, and it's just being dropped, not thrown. The polynomial represents the height in feet of the object after t seconds. So what does that mean? That means if I want to know how high they are in the air, I plug in time of 1 second, let's say. I plug in 1 second and I evaluate the number, and that's going to tell me how high off of the ground it is. Okay, part A. We want to write a polynomial that represents the distance between the penny and the paintbrush after t seconds. So let's think about this. Let's say, hypothetically speaking, the penny was 175 feet in the air, and at that same time, the paintbrush was 125 feet off the air. So if one's at 175 and one's at 125, how far away are they from each other? Well, 175 minus 125 is 50. They're 50 feet apart. That same concept is going to be true here. What I want to do is I want to find the distance of where the penny is at off of the ground. And then I'm going to subtract the different distance of the paintbrush from the ground. Once I do that, it's going to tell me how high in the air they are. Okay, so what represents the penny's height? It is this expression here. What represents the height of the paintbrush? Well, it's this thing, and I need to subtract them. Okay, so we should simplify this expression. Okay, we're going to do that by distributing a negative. So I distributed a negative, negative 16t squared turns into positive 16t squared, and positive 100 turns into negative 100. And then I combine the parts. So here my negative 16t squared and positive 16t squared cancel out. Negative 40t has no pair, so it's going to be just negative 40t. And then 100 and 200 can combine. So 200 and negative 100 are going to combine into positive 100. So that's part A. So now it's important to note that this expression represents the distance in between. Okay. So part B, interpret the coefficients of the polynomial in part A. What's that asking? Well, it's actually pretty simple. It basically wants to know, what does the negative 40 represent in this situation? And what does the 100 represent in this situation? Those are the only two things that it wants to know. So, going to be pretty easy to understand if we can just understand the relationship between time and D, the distance in between those two objects. Okay, so I'm going to start by playing a time of 0. So this would be right at the beginning. When I plug in 0, negative 40 times 0 is 0. 0 plus 100 is 100. Okay, now I'm going to do a time of 1. Negative 40 times 1 is negative 40. Negative 40 plus 1 is 60. And let's do one more. Time is 2. Negative 40 times 2 is negative 80. Negative 80 plus 100 is 20. Okay, so let's actually start with the 100 and what that means. Well, where do I see 100? Right here, when time is 0. So when time is 0 means the moment before they're dropped or thrown. So the initial distance between $100 is going to be the initial distance between the penny and the paintbrush. Okay, so that means at the starting point, they are 100 feet apart from each other. Now, where's this negative 40 coming from? I see it here. I don't see it in my table. Well, although you may not see it, it is there. And it's there in a sneaky way. Every 1 second, distance in between them decreases by 40. Every 1 second, the distance in between them decreases by 40. So what is the negative 40 representing? Well, it's representing the distance each second they get closer. So they're getting closer to each other because the penny's thrown and the paintbrush is just dropped. So the penny's going faster. So this represents the distance they get closer each second. So the negative 40 represents 40 meters closer every single 1 second. And that is example 6A, which is the word problem, which addresses our learning target 1. Okay, now in monitoring progress number 21, what they're asking you to do is the exact same thing. The only difference is it says, what if the polynomial negative 16t squared minus 25t plus 200 represents the height of the penny after t seconds? All it's saying is instead of this expression representing the penny, they're saying use this one now. Otherwise, everything is the same. Okay, now, hint of advice here, negative 40t is going to be that initial velocity of them throwing it. So this actually means that this one's being thrown, but not as hard as the other one. Okay, otherwise you're doing the exact same thing. Go ahead, pause the video, try number 21 on your own and check it off with me when you're done, which would be right now. So I'm assuming you've already paused the video and tried this problem. So let's go ahead and do it together. Okay, part A, we're going to represent the distance between them. So again, what we have to do is take the penny minus the paintbrush. The penny is going to be negative 16t squared minus 25t plus 200. And we're going to minus that same expression for the paintbrush above. Okay, simplify this expression here. Left one stays the same. Right side, opposite of each. So negative here will be positive here. Positive here will be negative here. So in this situation here, my negative 16t squareds cancel. Nothing combines with my negative 25t. And my 200 and my negative 100 are going to combine into positive 100. And that's part A. So the distance in between this penny and that paintbrush are going to be negative 25t plus 100. Okay, part B. Well, what does the negative 25 mean? Okay, again, this is going to be distance. They get closer every second. So every second, the penny, every 1 second, the penny and paintbrush are 25 feet closer. 25 feet closer, 25 feet closer. Okay, the 100, okay, is the initial distance between them. So the initial distance in between the two objects is 100 again, by happenstance. Okay, so that's it for the section. Here are your practice problems. Okay, so we're going to start with number 13 through 16. Okay, that is going to be a lot like the previous page where we created the table. Make sure you're creating the table, finding the leading coefficient, the degree, writing it in standard form, and the type of polynomial. Okay, next block is going to be 23 through, I believe, 30. 23 through 30, these are going to be the addition problems. Go ahead and do a handful of those. Okay, next one's going to be 31 through 36, which is subtraction problems. And then lastly, we have some word problems here, 51 through 53. So those are your practice problems before your learning targets. Go ahead and use those as some additional practice before you put your knowledge to the test. That's it for the lesson. I'll see you folks later.